So in this video, I'd like to introduce you to the three reciprocal trig functions. These are called cosecant, secant, and cotangent, and that's just 1 over each of the primary trig functions. So the primary trig functions are sine, cosine, and tangent. If we do 1 divided by sine theta, that's equal to what's called cosecant. So cosecant, and the short form for cosecant is CSC. So cosecant theta is equal to 1 divided by sine of theta. If you do 1 divided by cos of theta, so the reciprocal of cos theta, that's called a secant. And the short form for secant is just SEC. And the last one, 1 divided by tan theta is equal to the cotangent, is what we call that. The cotangent, the short form is just COT for cot. All right, so we can solve for all kinds of different things using reciprocal trig functions too. So all you have to do is just turn it into a primary trig function and then you're good to go. So secant of 225, well, secant is actually 1 divided by cos, right? So secant of 225 would be 1 divided by cos of 225. So what we really need to know here is what is cos of 225? And let's find this exactly. So we'll use our special angles for that. We can do that without a calculator. 225 is going to be right here, right? That would be 180 would be here, 270 would be there. So the angle from here to here, that must be 225 degrees there. Okay, just erase that so I've got more space though. All right, so I can draw my little triangle here, my special angles triangle. I should be able to recognize that that is a 45-degree triangle there. So that's 45 degrees. So remember the 45-degree triangle has sides 1 over root 2 and 1 over root 2. In this case, actually both of those are negative, right? The x value is negative 1 over root 2. And the y value of that triangle is also negative 1 over root 2. I'm looking for cos, so cos is the x value. So cos of 225 is, oh, sorry, I did too many 2's there, I got carried away. Cos of 225 is negative 1 over root 2. Exactly. Let's plug that in here to our equation for secant of 225. So secant of 225 degrees is 1 divided by cos of 225, but cos of 225 is negative 1 over root 2. So I have 1 divided by negative 1 over root 2. That's 1 times this fraction upside down, which would be negative root 2 divided by 1. That just makes negative root 2. So secant of 225 degrees is equal to negative root 2. By the way, there's not going to be a reciprocal trig function button on your calculator unless you have an unusual calculator. So how you calculate any of these reciprocal trig functions is you'll always use this method. So you'll turn your reciprocal trig function into a primary trig function, sine, cos, or tan. Use that and then do 1 divided by it to get the reciprocal trig function. Let's try cotangent of 150. So 150 degrees, right? This would be 90 here, right? This is 180, so 150 is like 30 less than 180, so that would be 150 degrees there. And if I draw my special triangle that goes with that, so that'd be the triangle that takes you right down to the x-axis, that must be a 30-degree triangle. If you remember your 30-degree triangles, the x side here is root 3 over 2. And notice that that's going to be negative. You're in the negative x-axis here. And this short side here is going to be a half. And that's going to be positive a half because it's in the positive y-axis there. All right, so what is cotangent of 150? Well, cotangent is going to be 1 divided by tan of 150. So cotangent of 150 is 1 over tan of 150. But that actually doesn't help me out because my special triangle here tells me what sine of 150 is and cos of 150, but it doesn't actually directly tell me tan. So what I need to do is plug in the fact that tan of 150 is equal to sine of 150 divided by cos of 150. Then you could use the fact that, well, this would be 1 divided by a fraction, right? So this would be 1 times the reciprocal of that fraction. So 1 times cos of 150 divided by sine of 150. Obviously, the multiplying by 1 there is not going to impact you at all, so that's just going to make cos of 150 over sine of 150. So what we've shown there is that the cotangent of an angle is equal to cos of that angle over sine of the same angle. All right, now we get to actually plug in our special angles here. So cos of 150, that's the x side here. That was negative root 3 over 2. Sine of 150 is the y side, that's a half. So I'm going to keep that top fraction the same, root 3 over 2, and multiply by the bottom fraction flips upside down, which is 2 over 1. Notice the 2's are going to cancel, and you'll be left with negative root 3. So all that to show, cotangent of 150 degrees is equal to negative root 3. All right, what if you're trying to solve for the angle? So what do you have secant of theta equals negative 2? And we have to work backwards to get our angle. Just like before, we're going to need to replace these reciprocal trig functions with the actual primary trig functions that they represent. So secant theta is equal to 1 over cos theta. So 1 over cos theta must equal negative 2. Now to solve for theta here, there's a few different ways to do it. I find the easiest way is this. So what you actually have on this side is a fraction, right? Negative 2 is negative 2 over 1. It's the same thing. If you have a fraction on both sides of an equal sign, and that's all you have, you don't have anything added here or anything fancy like that. You just have a fraction over here, a fraction over there. What you can do is flip both sides. That's nice because it gets the cos theta on top, which is where you want it to be. So we'll get cos theta over 1, which is just cos theta, is going to be equal to negative 1 over 2. Or in other words, cos theta equals negative a half. So looking at your unit circle here, this is going back a little bit of a review of our special triangles. Negative a half is over here on the x-axis because I'm dealing with cos. So the 2 points that have the x value of negative a half are here and here. So it's that angle and this angle here. And if we use our special triangles, this guy right here must be a 60-degree triangle, and that must also be a 60-degree triangle, which tells me that this angle here is 120 degrees. So that would be 60 shy of 180, right? And then this one here is 180 plus 60, so that would be 240 degrees there. So there's actually two answers here between 0 and 360 degrees. Theta would equal 120, and theta would also equal 240 degrees. Right, what if I have this? So 3 cosecant squared theta equals 4. So just like before, I need to replace that cosecant with what it is in terms of a primary trig ratio, so sine, cos, or tan. Cosecant theta is 1 divided by sine theta. So you'll rewrite this as 1 over sine squared theta instead of being cosecant squared theta. And that will equal 4 here. So if the squared just goes along with you, right? So if it's cosecant theta, then it would just be 1 over sine theta. If it's cosecant squared theta, then it's 1 over sine squared theta. So the squared just carries along. We're trying to solve for sine theta here. So this is a little trickier, but not too bad. Maybe one move you might want to do is multiply both sides by sine squared theta to get it off the bottom. So then multiply this side by sine squared theta as well. That cleans it off the bottom here. And now I have just 3 times 1 on this side, or 3. That'll equal 4 times sine squared theta. I clearly want to get rid of the 4, right, to get the sine squared theta on its own. So divide both sides by 4. That 4 cancels out. And I get sine squared theta equals 3 over 4. Next, I'm going to want to square root both sides to get rid of my squared here. So that kills the squared in the sine function. And I get the square root of 3 over the square root of 4. Square root of 3 I can't simplify, but the square root of 4 I can. Square root of 4 is 2. So I get sine of theta is equal to root 3 over 2, but watch out whenever you square root a number, remember that your solution is positive and negative. So remember the square root of, say, 9 is not just equal to 3, it's equal to positive and negative 3, because negative 3 times negative 3 is still 9. So the same is true here. The square root of 3 over 4 is going to be positive and negative root 3 over 2. Okay, so then when we go to find our solutions here, first I'll draw the sine theta equals positive root 3 over 2 solutions. So those would be, I'll do those in purple. Those will be up here. So root 3 over 2, positive root 3 over 2 is going to be somewhere around here. So that's like a y value of around 0.8, 0.9 over here. So that makes this angle and this angle here. And if I look at what those must be, those are special angles. So that's related to the 60-degree triangle in here. So that first one is indeed 60 degrees. So theta 1 will be 60 degrees. That's theta 1 there. My next angle, the angle all the way to there, so that's theta 2. Well, this is also related to the 60-degree triangle. It's 60 degrees shy of 180, so that must be 120, right? 180 minus 60. So theta 2 is 120. That's not all though, right? Because we have to do now the negative root 3 over 2. So that's going to be down here. These 2 points here will be when the y value is equal to negative root 3 over 2. So that's these angles here. The next one I'll do is theta 3. That's this one here. So theta 3 is going to be 60 degrees further than 180. So that must be 240. And the very last one, if I have room for it here, all the way around here, that's theta 4. Theta 4, you can see there's a 60-degree triangle in here. So it's 60 degrees shy of 360. So that means it must be 300 degrees. So those are my 4 solutions for theta to the equation 3 cosecant squared theta equals 4.